So the first type of calculation is mole to mole calculation. So using a conversion factor, or we can call a mole ratio. So the coefficient from the balanced equation are used to write conversion factors called mole ratio. With these mole ratios, you can relate moles of reactants to moles of product. What does that mean? Let's see. Nitrogen combines with the hydrogen to give ammonia. So when you balance this equation, you can see the coefficients 1, 3, and 2. Let's see how to write the mole ratio or the conversion factor. So for comparing nitrogen and hydrogen, we can see the coefficients. 1 mole of nitrogen combines with the 3 moles of hydrogen. So that is the conversion factor or mole ratio between nitrogen and hydrogen. And for ammonia and nitrogen, it is 2 moles of ammonia is produced from 1 mole of nitrogen. So that is the conversion factor or the mole ratio. So we are using the coefficients to write the mole ratio of hydrogen and ammonia now. So 3 moles of hydrogen produced 2 moles of ammonia. So 3 over 2. 3 moles of hydrogen over 2 moles of ammonia. That is what is called mole ratio or the conversion factor. So in this example, let us use this mole ratio we have just discussed and how to use that one to convert this mole to mole conversion here in this equation. How many moles of ammonia are produced when 0.6 moles of nitrogen reacts with the hydrogen? So we have to connect ammonia, how many moles of ammonia, and we have to connect nitrogen, which is 0.6 moles. So these are the two things we are connecting. So how many moles of ammonia? This one, and we are connecting nitrogen, these two. Okay, so let's see. So what is given? They have given 0.6 moles of nitrogen, correct? And what is the mole ratio to connect ammonia and nitrogen? Because we want to know how many moles of ammonia. So ammonia will go in the numerator and we have to take off nitrogen and nitrogen. This is called dimensional analysis. And when you write that conversion factor, and you can see that 1 mole of nitrogen, moles of nitrogen cancels, and you can just multiply 0.6 times 2, that will be 1.2 moles of ammonia. This is one method of conversion, which is the mole ratio or dimensional analysis using the conversion factor. Another method, another method is I think this is going to be much easier than using the conversion factor. Let's see. So the same question, how many moles of ammonia are produced when 0.6 moles of nitrogen, reacts, how many moles of ammonia are produced when 0.6 moles of nitrogen reacts with the hydrogen? So the same equation, balanced, coefficients are 1, 3, and 2. So what I will do here is, from the question, what are the things given? I will write just below the equation. So they are asking for the number of moles of ammonia, and I will write what is given, which is 0.6 moles of nitrogen. And from the equation, I will write how many moles of nitrogen are in the balanced chemical equation, which is nothing but 1 mole here. And I have 2 moles of ammonia. And then I will just cross multiply. Okay, so then we can get the answer. 1 mole of nitrogen times how many moles of ammonia will give you 0.6 moles of nitrogen times 2 moles of ammonia. And when you simplify, you can get that answer. I think it's going to be the easiest way for the conversion instead of using the factor, or you can, that's up to you, whichever is easy you can follow. So this is a check for understanding question. You try yourself and let us check the answer later. Okay, so the next one is mass to mass calculation or conversion. So the same question, but just the number is different and the unit is different. How many grams of ammonia are produced when 14 grams of nitrogen reacts with the hydrogen? I mean the same equation, okay, same reaction. So let us write the equation first. As we have seen before, nitrogen plus hydrogen gives you ammonia, and the coefficients are here 1, 3, and 2, which is making this equation a balanced chemical equation. So what I will do from the question, what are the things given, I'm going to write it down. So the first thing is how many grams of ammonia produced from 14 grams of nitrogen. So I will write under the reactant and the product according to the question. And now from the equation, I will write how many grams of nitrogen are here. If you look in the periodic table, you can see each nitrogen is 14 grams. So I have 2 nitrogen here. That subscript is 2. So 2 times 14, 28. And I will find same way the mass of ammonia here for 2 moles. So 2 times 14 plus 3 times 1 because we have 3 hydrogen here. So that will give you 34. And when you cross multiply, you can get the answer. 34 grams of ammonia. So number of grams of ammonia will be 14 times 34 divided by 28. 17 grams of ammonia will be produced. So that is mass to mass.